Welcome back. In this lesson, we're diving into one of the most fundamental structures in TypeScript, objects. Let's begin by creating a basic object and learn how to define its type properly. Here, we're defining a constant named person that stores an object. We're giving it two properties, name and age. Right now, we haven't explicitly set the type for this object, but TypeScript is smart. It automatically infers the best possible type based on the given values. Since Alice is a string and 25 is a number, TypeScript assigns the type, string and number. This is known as type inference. However, for stronger type safety, we can also choose to explicitly define it. Now let's log it to the console and see the result. We'll compile the code using the npxtsc command. Let's try updating the value of the age property in this object. Let's compile the code again and check the result in the console. As you can see, it was successfully updated without any errors. However, if we try to assign a string value to this property, TypeScript will throw an error. In other words, property values in objects can only be updated with values of the correct type. We're adding a property that doesn't exist in the object's type, City, Wonderland. As you can see, we get an error saying that this property is not defined in the type. Normally, JavaScript wouldn't complain here. To fix the error, we go to the type definition and add city string. The error on that line disappears, but now the object itself throws an error, because TypeScript expects all properties defined in the type to be present in the object. So, what if we need to add a property later on? In that case, we can use an optional property. For example, if we want to include a city but not make it mandatory, we can write ? The question mark indicates that the city property is optional. It may or may not be included in the object. Let's compile the code again and check the result in the console. When we check the console, we can see that the city property and its value have been added to the object without any issues. Now let's write down our note. If no data type is explicitly specified, TypeScript will infer the most appropriate type based on the values provided. All right, now let's continue with a new topic, object destructuring. Let's assign the property values of the person object to variables with the same names. If you see an error on the name property, don't worry. It's not your code. This happens because name is a global identifier in browser environments. To fix this, consider using a different name like person name. However, this time we get an error because of the type definition in the code above. Here's how we can fix it all. Let's print it to the console. We compile the code again and check the result. We can see that the property values have been successfully assigned to the variables. Next topic, object readonly. We define a new constant where the first property is a string and the second is a number. Then we update the age value inside it. As expected, there's no issue. But what if we want to prevent this value from being updated? That's right, we use the readonly keyword. We can see an error is thrown on the line below. However, in this case, we need to apply it to each property individually. For example, the line where we try to change age throws an error, but when we update the other property, it works just fine. Let's compile the code again and check the result in the console. And when we check the console, we see that the name has been successfully updated to Jane. So, how can we make the entire object completely immutable? If we want to make the entire object immutable, we can use Object.freeze method. This prevents any changes to the object's properties at runtime. It's a good way to ensure that your data remains constant. Now, let's try to change the value of the name property. As you can see, it doesn't throw any error here because this is a JavaScript method. Let's log it to the console and check the result. Let's compile the code again and check the result in the console. When we check the console, we see that an error occurred, not while writing the code, but during the JavaScript compilation. Now let's write down our note. If we want to make the entire object read-only, we can use Object.freeze method. Let's move on to our final topic, the object spread operator. We're now defining a new object called person3. Using the spread operator, we copy all properties from person2 into person3 and then add 2 more properties. One that already exists in person2 and 1 new property. In other words, we are performing both an update and an addition. Now let's add their types. We specify that city is of type string. After defining the type for the new property, you'll notice that TypeScript also expects the other properties to be typed. If we don't explicitly write any types, TypeScript infers them automatically. However, if we type one property and leave the others untyped, it results in an error. So we add the missing type definitions as well. Then we head over to the console to check the output. But right now, we can't compile the code because there's still an error from the previous freeze method. This is the line that's throwing an error in JS file. To fix this, we comment out the code where freeze was used. After that, we compile the code again and check the result. As you can see, the age property was updated and the city property was added successfully. In this way, we use the spread operator to copy an existing object into a new one while making updates. That wraps up all the code we wrote today. To sum up, TypeScript can infer object types automatically. You can define types explicitly for clarity and control. Optional properties make your objects flexible. Use Object.freeze to prevent changes. That's it for today's lesson. In the next video, we'll explore functions and how to type them correctly. Thanks for watching. Stay curious and keep building.